Good morning, everyone. Maybe we can give ourselves several minutes. We can start at 11:03. So I will start immediately. My name is Wycliffe Mwangi. I'm a technical sales manager for GoodWe Technologies in the East and West African region. I gradually welcome you to our Africa Pro Sales webinars. This is a series of webinars to introduce our new products, to add value and showcase our existing portfolio. And today we'll be doing the company introduction and do our residential inverters. So I'm joined with my colleagues, David, who will be introducing himself when he starts the next. But maybe, David, you can introduce yourself.
Hi, I'm David Havenga, or some people say Havenga. Nice to meet you. I'm the technical manager for the African Middle Eastern region, and I'll be doing the more technical section of the webinar for us. Thank you, Wycliffe.
Okay, good. I'll be introducing our company profiles and our portfolio in terms of what we do manufacture. So GoodWe is one of the leading inverter manufacturing company. We pride ourselves being among the top inverter manufacturing company with a wide portfolio of products. So our vision is to driving the energy transition, the smart energy transition, with a mission to be the main driving force in the global energy transition by creating a sustainable future for the earth, for mankind, and also for future generations. So far, we have installed more than 4 million units of our products globally, and this translates to around 78,000 gigawatts hour of power, annual power that is generated globally. So in terms of the carbon dioxide that we have offset from the atmosphere, we offset around 7,800 million tons of carbon dioxide across the globe. So our company has had several milestones. It was established in 2010, and sure, we really have grown by having different milestones. So some of the milestones include establishment of our R&D centers, being such as a listing in Shanghai Stock Exchange, being licensed by General Electric as one of the licensed partners, establishment of different subsidiaries across the globe, and winning several awards that I'm going to showcase later in the subsequent slides, such as the TÜV and Quality Award or Matters Award by leading institutions. So we really have grown over over now 13 years of operations, and we continue to subsequently grow. So in terms of our GoodWe family, we have now a total heads count of fairly over 4,600 employees, of which 800 are focused in the research and development. So in this case, it's prudent to also mention that the 10% of our company's revenue budget is really focused on this department to ensure that we are churning out new products that are meeting the global world demand. So we also have overseas employees with different subsidiaries and different offices across the globe. So in Africa, we have an office in Kenya, Nairobi. We also have an office in Johannesburg and a representative in Cape Town. So we are really trying to cover our market in a way that is really sustainable. In terms of the global sales revenue, last year we did around 1.2 billion USD. So if you can check on that graph, it means we are really one of the fastest growing inverter company in the world. So if you look from the growth from 2016 to now 2022, it shows our products are being accepted globally by different stakeholders and world-renowned brands. So in terms of award, we have been successful in getting the right quality awards, such as the Red Dot Design, the TÜV or Quality Matters Awards. We have been rated among one of the top inverter suppliers by Wood Mackenzie. And we in 2022, we were given a silver medal by EcoVadis, which entails the ESG topic. So we are really concerned about the ESG topics as a company. So in terms of the production capacity, GoodWe has over 30 gigawatt solar inverters production capacity and 2.1 gigawatt hour battery storage capacity. Battery capacity, that is in terms of the manufacturing. In terms of the global installations, we have an accumulative capacity of 52 gigawatts of our products that has been installed worldwide. In this case, 23 gigawatts are in the residential space and 21 gigawatts are in the commercial and industrial space. Recently, we also started our utility business with already over 4 gigawatts already installed with our utility solutions. We also have our energy storage solutions from the residential and recently the commercial and industrial solutions. So we define ourselves as a quality inverter manufacturing company. So in this case, we are the licensed partner by General Electric. So it's literally no-brainer to say that we produce quality products. We pride ourselves being a quality source solution products provider. So we really have a wide portfolio of products from residential inverters as small as 700 watts all the way to utility scale inverters of up to 250 kilowatt. We also have our lithium battery solutions from low voltage to high voltage. We also have our hybrid inverters, small inverters from 3 kilowatt all the way to 100 kilowatt solution inverters. We also have our smart energy monitoring systems. In this case, we have our smart energy monitoring system, our also accessories such as the meters. Yeah, so we really have a robust product portfolio to meet the different segregated market needs. So this is some of the pictures for our solutions. These are our inverters. And just briefly, I'll discuss what is unique about us. What is our unique selling price? Why would we? So we have residential string inverters, small inverters. Our smallest inverter family is called the XS family. Very small in the size of the A4 size full scale. So in this case, it is 700 watts. And that family goes up to 3 kilowatts. So it comes with 1 MPPT. We have the next family called the SDT G2 Plus series from 4 kilowatt all the way to 20 kilowatt and comes with 2 trackers. Then we have single phase string inverters called the MS series from 5 to 10 kilowatt comes with 3 MPPTs. And then we have another special inverter called the DNS G3 series from 3 to 6 kilowatt comes with 2 MPPTs. So some of the unique features of these inverters include DC oversizing of up to 100%. They are really compact and lightweight. They support the ARC4 circuit interrupter and have a really large maximum input current of up to 25 amperes. Our inverters comes with multiple trackers of up to 3 MPPT for the residential. So at 20 kilowatts coming with 3 MPPT gives you that flexibility in terms of design, especially for the multi-angled roof spaces. So we have our hybrid inverters. So in this case, we have our ET Plus series inverters, 16 amperes. These are 3-phase inverters, hybrid inverters from 5 kilowatt all the way to 10 kilowatts, comes with 2 MPPTs. We have our EH Plus series. These are single-phase hybrid inverters, which support high voltage batteries and comes in the sizes of 3.6 all the way to 6 kilowatt. Then we have a unique product called the ESG2 series. So the ESG2 series is our single phase inverters, comes in the sizes of 3 to 6 kilowatts and comes with up to 2 MPPTs. So some of the unique features of our hybrid or energy storage inverters is that they have a UPS level switching time of less than 10 ms. You can do smart home integration, support DC oversizing of up to 150%. They are really compact and lightweight. So, for example, we have our ESG2 series. This is our hybrid inverters for single phase. Support also low voltage batteries. Comes in the sizes of 3, 3.65, and 6 kilowatt. They can support a battery bank of up to 32 kilowatt hour. This is our battery bank. That is our Rings Home U. They have that aspect of black start capability and are compatible with other third-party approved batteries. So the unique feature about this is that they also have two outputs, that is the backup output and also the on-grid output, and can support genset integration without requiring a third-party controller. So the other thing about the ESG2 is that you can parallel up to 3 pieces in a master-slave relationship using EZ-Link program. So David is going to talk more about the ESG2 in details. So we also have our ET series. The ET series is our 3-phase inverters. So we have the ET plus inverters from 5 to 10 kilowatt, and then we have a hybrid inverters from 15 kilowatts, 20 kilowatts, 25, and 30 kilowatts. So this is all in one hybrid inverters. So they comes, some of the unique features of these inverters is that they also have the UPS level switching time, have a really strong backup ability, support 100% unbalanced phase output. Ensure they also have another special feature such as the ripple control receiver to control the feeding power from the grid when it is necessary. We have our storage unit for the residential series. We have low voltage batteries called the Rings Home U series. This comes in the sizes of 5.4 kilowatt hour, and you can stack 6 pieces to get a larger backup of up to 32.4 kilowatt hour. Then we have our high voltage. It's good to mention that the Rings Home U series is compatible with our ESG2 single phase inverters. Then we have our Rings Home F series. These are high voltage inverters. So in this case, you can stack a minimum of 6.6 kilowatt hour and build up to 16.4 kilowatt hour. And in case you require to build larger backups with our Rings Home F series plus, you can parallel up to 8 of the Rings Home F Plus series to get a larger backup of up to 131 kilowatt hours. So the unique features of our battery is that they are really plug and play, easy to commission. They also support the automatic module detection. We can do remote control and firmware updates. Yeah, and they are also IP65 and IP55 rated for outdoor applications. So we also have our on-grid inverters for the commercial and industrial series. So in this case, we have small inverters called the SDT. So that is small dual trackers, comes in the sizes of 25 kilowatts and comes with 2 MPPTs. We also have multiple trackers inverters such as the SMT, 25 to 36 kilowatts, comes with 3 MPPTs. So we also have the SMT series 50 and 60 kilowatts. In this case, the 50 kilowatt comes with up to 5 MPPTs, and the 60 kilowatts comes with up to 6 MPPTs. We have the large commercial and industrial inverters in the sizes of 100, 110, and 120. So 110 comes in the sizes of, comes with 10 MPPTs, while the 120 comes with up to 12 MPPTs. So really, this gives you multiple trackers to do as in to reduce the losses when you're doing your design. So one of the unique features about inverters is that they have a really strong temperature adaptability. So in this case, our inverters, we only direct at 50 degrees. So at 50 degrees, our HT will output 100 kilowatts. So at temperatures below 45 degrees, then our commercial and industrial inverters will always do what we call AC overloading. So ideally, at 45 degrees, our 100 kilowatt is 110 kilowatt. So they also support FCI. You can do DC oversizing of up to 50%. Then they also support the power line communication series. So we really have very nice solutions in the commercial and industrial inverter series. So we also have, sorry for that. We also have our energy storage solutions for the commercial and industrial solutions. So we have our Ring C series. Our Ring C series is our commercial and industrial storage battery. So these are high voltage batteries in the sizes of 100 kilowatt hour all the way to 156 kilowatt hour. We also have our hybrid inverters called the ETC series, and also AC coupled inverters called the BTC series. So this comes in the sizes of 50 and 100 kilowatt. Yeah, in terms of their rating. So in case you have a solution where you need to do energy storage solution for commercial and industrial solution, feel free to reach us out. So GoodWe also manufactures the EV chargers. The EV chargers is becoming quite a hot topic in our market. So in this case, we have single phase inverters, 7 kilowatt, and 3-phase inverters in the sizes of 11 kilowatt and 22 kilowatt. So some of the unique features of these solar powered EV chargers is that they are compatible with all EV brands, and then you can monitor the charging cycles using our smart energy monitoring systems. So they also come with the charging cable already included. So thank you. Over to you, David.
Thank you very much, Wycliffe. Let me just share my screen now. So I'll be taking us a bit more in depth into the product, as well as a bit of installation and troubleshooting. I hope everyone can hear me nice and clearly.
Yes, we can.
So first up, we'll look at the ES Generation 2. Here's a typical system diagram for the ESG2. You've got your inverter, your backup supply, grid connection, your solar panels and your batteries, as well as your included meter. The features of the device is installation with plug-and-play design, easy commissioning in an all-in-one app, nice mute soft style to fit in home design, as well as integrated PV isolation. You can form a paralleling system with these devices. I will go into more depth later. It works essentially in a master-slave configuration where you've got a smart dongle that you use to create a master inverter, and then from there on, add on more devices. With all of our hybrids, not just the ESG2, so all of our newer hybrids all have the smart load control integrated that you can control from the SolarGo application. So you can connect a relay to it. It's got a dry contact that you can switch based on backup load. So if you want to switch a load into the backup of the inverter, if you want to switch certain loads on at certain times, or if you just want a power switch mode. So once you reach X amount of PV production, switch on certain loads. So this is very nice for off-grid situations to make sure you charge our battery full. Once we've got X amount of solar, then we can switch on a load to the backup. And once the batteries start draining to a certain level, we can switch that load off again. So for hot water heating in off-grid scenarios, quite useful. As mentioned, yeah, you can see we can select when it will open, when it will close, based on battery percentage. Then the ES Generation 2 is our only device with this function, which is generator integration. So we also have a separate dry contact to switch on automatic start generators. So with this, we can also configure different battery percentages, or we can just manually switch it on as well. So if you have an ATS site with an auto start generator, we can program that to say once the batteries reach a certain percentage, that they should start the generator, charge the batteries up until they are full or until the percentage you like, and then we switch the generator off again. But with our devices, we have the smart communication systems. So with the smart dongle that you use for paralleling as well, you can achieve some of the IEEE 2030.5, which is American required standard. There is a lot. All of our devices come standard with Wi-Fi. But if you have any other monitoring requirements, then extend that with the smart dongle. Then safety protection. We offer extra safety protection. So integrated on our standard devices is type 2 DC surge protection and type 3 AC surge protection. You can also enable a alarm so that should that surge protection fail or trigger, then you will receive alarm locally and on the same tool. One of our optional features that you can get when ordering our devices is the arc fault detection. This isn't something we'd really use too much in Africa, but if we have sensitive installations such as petroleum, factories or anything like that, where they need a higher level of protection, this can be ordered with the device to ensure a higher level of safety. Our hybrid inverters offer PV overloading. The new ETs as well as the ESG2 has this feature. What we mean with PV overloading, you can put 1.5 times PV on the inverter, and that is usable PV. So you can oversize it even larger than that for oversizing sake, but the usable PV on this inverter is 1.5 times the inverter rating. So on the 5 kilowatt inverter, you'll see we can use 7.5 kilowatts of PV. That will give us our 5 kilowatts of AC while simultaneously charging at 2.5 kilowatts. And obviously, it depends. So if your load is lower, it will use more to charge the batteries, up to a maximum of 5 kilowatts charging the batteries, and then the rest can go to the AC side. This gives us a lot of flexibility, especially in off-grid scenarios where you might need a larger PV system, but you don't necessarily need a larger inverter. And just to mention also the 6 kilowatt, we can put 9 kilowatts of PV. So what this oversizing does, as you can see in this graph, so typical PV oversizing, as you'll see, typical PV oversizing will just make us reach our peak sooner in the morning and stop the peak later in the day. So you'll have a flat curve here. But with our oversizing, as you see, all the excess energy can be used to charge the batteries. So then you don't lose this energy. With typical oversizing, you would lose all of this energy during the peak of the day. Then the ESG2's backup overload. So the ESG2 can backup overload up to 2 times part number, up to a maximum of 10 kilowatts. So the 5 and the 6 kilowatt both do 10 kilowatts overload on the backup. So when the grid is available, it can constantly give you 10 kilowatt output on the backup side. When we have got sufficient solar and batteries available, we can also go up to the 10 kilowatt. And then we will be limited 10 seconds if we only have batteries, and overload up to 10 kilowatt only for 10 seconds if we only have batteries. So during the day, we can run more loads. As long as we have a good solar day, we can run the loads as well as continuing to work the system and not have a trip off on overload. These devices are compatible with a wide range of batteries. You can consult our battery compatibility sheet for that. We do also offer some local South African brands or brands that are sold locally in Africa. So we can also consult the sales consultant for those. Does anyone have any questions for us before we move on to the ET15? So keep in mind, we will go through the installation now of the ESG2 as well as troubleshooting. If there's any other questions, then we'll keep going. So please ask them as we go on. So if anything comes to mind, please let us know. So just looking at the parameters of the ET15 to 30. So yeah, we have essentially 4 models, the 15 kilowatt, the 20 kilowatt, the 25 and the 30 kilowatt. You'll see the 29.9, that's mainly for Europe, for regulation wise. So the 15 and the 20 both have 2 MPPTs and they both have 1 battery input. With the 25 and the 30 have 3 MPPTs and they have dual battery input, so 2 battery input. So these are also high voltage batteries on these inverters. So our ETs, which is one of the features that we have, is the unbalanced load output. So on the off-grid output of the inverter, the backup, we always have the unbalanced output to run loads in an unbalanced manner. So we always do require neutral for the inverter so we can run these unbalanced loads. But then when we have zero export, which we do have in many countries in Africa, we're not allowed to export any power to the grid. Then normally your conventional export power limiting is either going to be lowest phase limiting or average phase limiting. So when we're not allowed any export at all, then we'd use lowest phase limiting, which means your inverter will only produce on each phase the lowest consumption from utility. So then you lose a lot of energy. You're still consuming quite a bit of energy from the grid, and any small loads like that we won't be able to cover. But with the unbalanced output on our ET devices, it's individual phase limits. So it will give you what you need per phase up to the maximum of the inverters per phase output. Always keep in mind the 3-phase inverters, you'll have your 30 kilowatt divided by 3. So it means 10 kilowatt per phase maximum in output. So if your loads are like this, 10, 5, and 1, the inverter will produce that and ensure zero export on each phase. So it will give you a great advantage in the savings compared to your conventional zero export. Because conventional export, yeah, your inverter would actually be producing only 3 kilowatt because your lowest phase is 1 kilowatt. It produces 1 kilowatt on each phase. So it is very inconvenient for most household installations. The inverter also, if we install it just as a UPS with grid charging, we'll also do unbalanced charging, so especially for customers that have KVR chargers. You know, with KVR billing, you are billed on your maximum demand charge. So this will help to reduce the maximum demand and also won't add to the maximum demand. So it will see where you're consuming the most power and draw power from the grid in an even way to make sure that the consumption is equal. As mentioned, that smart load control is also available on these devices. And then we have the separate battery inputs. So let's talk about that. So the 15 and the 20 have one battery input. The 25 and the 30 have 2 separate battery inputs. So those battery inputs can be used in parallel, or you can have 2 completely different batteries on the inverter. If one battery is available today, let's say today the Lynx F is available, we install that. We can also parallel those batteries. And 6 months down the line or a year down the line, the customer wants to install more batteries. Either you could use another pair of Lynx F on the second input, or you can install a BYD battery on the second input, depends what's available solution at that time. It gives you a lot of flexibility. So even if you install a bank now and you use both inputs on a bank, you know, a year down the line, you don't want to add more batteries to that same bank in parallel, because it will reduce the lifespan of the new batteries. You can then use that separately over to one input and put all your new batteries on the second input. That gives you a lot of flexibility. And these devices can also work in peak shaving mode. So if you have customers with KVR billing and they want to reduce that peak demand from the utility supplier, they can install this device and configure it. So what you'll do is you'll set your limit. So once your consumption reaches X amount, it will start to discharge the battery for any amount that's above X. And yes, then there's the easy commissioning with SolarGo, but I'll go through all the screenshots. I'll be commissioning that in the next section. But the convenient maintenance monitoring with the SEMS platform. Keep in mind these screenshots here are from the new SEMS app that we'll be releasing later in this year. And now we can move over to the installation tracking. What will you do? So first of all, the GoodWe installation manual. You can get it on our website as well on the product pages. In the past, we also had another app called PV Master. PV Master has been discontinued and will no longer be used. So any installers familiar with GoodWe will know that we no longer will use PV Master. SolarGo will be used for all of our products going forward. And then lastly, your general tools and personal equipment. Now we look at commissioning. So commissioning, we use the SolarGo app, and for monitoring, we use the SEMS portal. SEMS portal we can also use for remote configuration. So what do we do when we first start? So all components that you require for the installation of the inverter, connection to the inverter, will all be provided with the inverter. We always have the one box solution with our hybrid inverter. So there's no extra accessories that you require. Only for paralleling and things like that, there's extra accessories that you may require, but everything for the device will be in the box. It's very important to first consult your manual, check that you have all your components. Very often when we open the box, we might hang the inverter first and all the other components we throw to one side, and then things are lost in the installation. It's very important to check what you have, what you've received in the box, what's in the accessories. So any external connector, any proprietary connector, anything like that, keep it safe, keep it one side, and also install all of them onto the device, because you never know when you might need them in future. Unfortunately, too many times we have found customers, I don't need this today. They will throw it in the back of their van, and 2-3 months down the line, they might need it, and then it is gone. So if you can install it on the device, always rather install it on the device and leave it on site, so that if you do need to use that accessory, that it is there. The inverter positioning, all of this you can find also in the user manuals, and you can just double check in the user manuals before installing. So our hybrid inverters are IP65 rated. They can be installed outdoors, but we need to make sure that they are not in direct sunlight, not in direct weather conditions, and do not have direct snowfall on them. The inverters can be installed at a backwards incline. We should not install them sideways or leaning forwards. This is all about heat dissipation. The installation is very important. Area of installation, where we're installing it, making sure we have enough volume around the device for it to be able to release all of the heat. So fixing the mounting plate, that's not too tricky. Next, we look at AC connection. Also, before you go to site sizing, you can also consult our user manuals on the recommended cable sizes to use. As you'll see, the manual recommends 6 to 10 millimeters in the user manual. Put it in another slide, 6 to 10. That means the 3 kilowatt model will use 6 millimeter cable for the AC, and the 6 kilowatt model you'll use 10 millimeter. So always keep that in mind. Make sure we are using the correct cable sizing. Next, we look at breaker sizing. My recommendations for breaker sizing. So due to that overload capability, the maximum consumption from utility, always important to keep these in mind. Very often we install a 3 kilowatt inverter. We might think 3 kilowatts. We only put a 25 amp breaker on it, but it can overload, and customers generally do tend to overload. Always make sure we install the right size cables and the right size breakers. It's never good when we're consuming power from utility that the breaker switches off. So then inverter information. So there's 2 places to find information on the inverter. So we've got the LEDs. So when it is in operation, we can inspect the LEDs and see. Next, we have the technical information, which will be on the side of the inverter, as well as your serial number and check code. This you require when registering on the SEMS portal. We do also have a QR code here that you can use from the SEMS mobile app to register the device. Instead of manually typing out the serial number and the check code, the QR code will give it all to us automatically. So here's an overview of the device. At the bottom, we can see we've got our battery inputs. We've got the communication, the Wi-Fi, battery and meter communication. Here we have our multifunction port. So this is used for paralleling. It's used for the relays, for the load relays, as well as the generated relay. So all of that is here in the multifunction port. So then we have our MPPTs, our DC strings, our DC switch, as well as our backup and on-grid connectors. Front we have the LEDs, and in the back we've got the mounting and the fins. We're going through the connections of the inverter. It is very important to install correct grounding on the inverters. Low voltage inverters aren't as susceptible to interruptions for low voltage battery inverters when grounding is not there, but it can cause a failure of the device because the cabinet and all of that can build up induction. That induction can lead to issues down the line. It's very important. This is in the user manual that we install sufficient grounding not only on the AC terminals but also on any metallic part. Any external metallic part should have a grounding connection connected to it, and they should all be equally potentially bonded and connected to the home's grounding. It's always a good practice as well when installing a solar system to install some extra earth spikes as well. Make sure should the utilities grounding fail that we do have sufficient grounding on the site. Next is the DC cables. Won't go into too much in depth there. I'm sure you are all very familiar with installing the DC cables. The next, our battery connection. So with our battery connection, we have the cover here as well as the lugs included. It's always good to make sure that you are use a proper crimping tool to crimp these and the correct size cables. So you'll see we recommend a 20 to 35 millimeter cable. So 20 mil if you're using a 3 kilowatt device, 35 mil if you're using a 5 or a 6 kilowatt device. These are the recommendations, especially if you are installing a bigger battery bank. And this is all in the user manual. Then our Lynx U batteries. So with the batteries, we include these connectors. The Amphenol battery connectors are included. They do not have pre-made cables on them. Essentially, you'll insert the cables. So there are 2 grommets for different sizes. One will give you a 20 mil and one for the 35 mil. We need to make sure we install the right cable with the right grommet in there and crimp it with a proper crimping tool. And always make sure to hear the click when we install them. So when we're installing multiple batteries, there's an overview as an example as well. So we have DC cables connected to the first battery. But in all honesty, I wouldn't follow this methodology. It's always best to do it slightly different. So I would take the red from here, this port, and disconnect this one. So for the balance of the batteries, this is the best method. I'll just have to redraw this in the slide a bit more professionally for future. I always recommend to install neutral from the one side and live to the other side at the end of the bank. That way you will have equal potential amongst all of your batteries and they can evenly charge without any unbalance. So your communications, you'll go to your first battery like that, and then the rest of the batteries are daisy chained. And then at the end of the line, we install a termination resistor. The BMS communication to the inverter. As you'll see, we've got these nice little connectors. You simply unscrew it, you'll remove the blank cap, then you'll push the cable through, clip it into the connector first, and then we can screw and close the connector. So always make sure you click the cable in first. So the cable here needs to be clicked in first. So you hear the click and it is nicely secured. And we can put the outside cover down and lock it to the cable to make sure it cannot be pulled out. It's always important, so before connecting the AC side, check the grid values, make sure that everything is correct, and the AC breakers between the inverter and the grid connection is 1.25, the X-rated current. But I already have the recommendations for a few different models in one of my earlier slides. So on the AC side, it's always good you really need to make sure to plug the correct ones in the correct ports. You've got a backup port, which is for your essential loads, and then the on-grid port, which is for your grid connection, your bidirectional grid connection. So always make sure that you put the grid connection in the on-grid port, because if you plug the grid into the backup, you can cause the device to fail because you're injecting voltage into an output port. So always make sure you are plugging the grid into the correct port. Always verify before you connect it to the device that you put the correct one in. You'll see in the user manual, we also do have recommendations for the screw type as well as the torque. If you want to make sure you are installing it and crimping your cable sufficiently, you can use a screwdriver with a torque setting. The next is the smart meter installation. It's very important to install the smart meter correctly. So the inverter does have the communication pre-wired. That cable is 15 meters long. Should the smart meter be further away than that 15 meters, it's fine. You can replace that cable entirely. So you'll replace the communication cable. Please never use extenders to extend the cable. Take that cable out, put a new cable in, and you can put it up to 100 meters away from the inverter. You can install up to 100-meter long cable. Make sure it's a nice insulated cable, so Cat 6 or Cat 5e. insulated network cable, and then you can run that about 100 meters away from the inverter. So the placement is very important. Your smart meter needs to be installed and powered by the grid, so as close to the utility meter as you can. So install the meter, the meter's power supply, close to the utility meter as you can, and then the CT in the same position as well. I'll go a bit more into depth into the smart meter, as well as show the three-phase smart meter, because that's normally where a bit of our problems come from. It's very important, the meter installation. So the CT is there to measure the electricity to and from the grid, especially for zero export. When we need to limit the power, it needs to be in the right place so we can see our non-essential loads. So the inverter can also provide us energy for the non-essential loads, as well as limit the export to utility. So with the three-phase, because I'm talking about the ET as well in this, but our installation here is only the ES. The three-phase meter is slightly more complicated to install. It's very important to make sure. So the CT cables here on top, you'll notice that A is on the right-hand side, but L1, which is A, is here on the left-hand side. It's very important to note this, that the bottom is from left to right, and the top is from right to left. You will find this in the user manual as well, so please always pay attention to that. I know sometimes we need to remove the CTs off the top of the smart meter, because the smart meter might not fit into the customer's distribution box. So we need to install an external box next to that. Then we'll install the smart meter, remove the CTs, and place them back on the device. It's very important to check that we put the right CTs on in the right place, and that the voltage input to the meter is the correct voltage and the correct input. And then lastly, the direction of the CT should always be K to L, so from house to grid. So K is house, L is the grid. It's very important that we do this correctly. You'll see also where we install the CTs, and the supply to the meter is very important. So as close to the utility meter as possible, our voltage supply, and then the CTs as close to the utility meter as possible. Never between the inverter and loads, never below the inverter. We should also never power the meter from the backup. As you'll see, here's a picture of the stickers that are on the CTs. I've never found any of these stickers ever to be wrong. They are always correct. The only time they are wrong is when we have the incorrect voltage input, or we have the incorrect wiring when we returned the CT to the meter. The arrow must always be pointing towards the grid. And yes, the single phase is much easier. You have one CT and you have one grid input. It makes it a lot easier, where the three phase is a little bit more complicated. Next, we have the internet communication. So you'll find in the accessories the Wi-Fi module, or the Wi-Fi and LAN module, that you can then just insert into the COM1 connector. Then we connect to the inverter. So there's two ways to connect and commission the inverter. One, we connect to solar Wi-Fi. So solar Wi-Fi with the password 123456778. Alternatively, with all our new devices, the ESG2, the ET15 to 30, they all have built-in Bluetooth. So we can simply open the app. We will see the two options. So if we connect it to the Wi-Fi, so the hotspot of the inverter, we can do that as well. Then we'll see the two in the list. You'll see solar Wi-Fi when you've connected it to the Wi-Fi, or you'll see solar Bluetooth when you're next to it and have Bluetooth open. So once we connect to it, we'll log into Solar Go. As you'll see here in Solar Go, we've got the bottom menu with the home parameters and more. In the home screen, you've got the overview. You can check the live data on the top in the flow diagram. It also shows some of the current settings. So what is the safety code? What is the working mode that's configured? The battery model, the BMS status, meter status, backup supply, and export power limit. In the parameters, here you'll find a lot more in-depth information about the device, such as the serial number, the firmware version on the device, the PV voltage inputs and currents, grid voltage inputs and currents, the backup output voltage, and all that information. Here's where you can check all your voltages and make sure that everything is correct. Next, we'll go over to basic settings. In the latest Solar Go, this has slightly changed. There's a new guide settings to set some of the more basic settings, and then we have basic settings separately. Unfortunately, we don't have updated presentation for the latest version of Solar Go, but there is a slight change in the settings. But all of the after settings I'll show you is more or less the same, except we'll use the first function, which is the new simple settings, and then basic settings thereafter. So first we'll select our safety country. So for this, it depends which country are, what regulation we're working on. So for this, we'll select Africa, we might select Germany. An alternative, when we need a wider range input, we select 50 Hertz default. I don't think anywhere in Africa we should select the 50 Hertz LV default. This 50 Hertz LV default is for 120 volt grids. So please keep in mind that the LV default that you can see here in the screen, we should never use that. Please never use that, because then the device will never connect to the grid. So if we need a wide range input, we can use 50 grid default. So that doesn't comply to any national standards. That's just a wide operating range. So if the grid voltage is quite unstable there, we can use that. But if we want our inverter to protect everything on the output, make sure that the voltage is high, then we will select a grid code such as South Africa or whatever grid code or grid compliance your country complies to. Next, we'll select our working mode. So you have general mode, which will be the default. So that is designed for most self-consumption. Next is backup mode. The backup mode is used to essentially keep our batteries full. So it will always keep the batteries full and only discharge when the grid fails. That also charges the batteries like a UPS. So it is a slow charge on the batteries to always keep them full. Next is economic mode. Economic mode is used for time of use tariffs. Typically, we can also use it for a bit more dynamic charge and discharge. Like for instance, I use it in the morning to make sure my battery is at a certain percentage. So should the power fail in the morning, when the family wants to make some coffee in the morning, there will always be battery capacity available. But I don't make it full in the morning because I want the son to also do some charging. And then in the evening, the same thing as well. And then lastly, for the ET and bigger devices, we also have the peak shaving mode. So we can select the work mode or peak shaving mode. Thereafter, we select our batteries. You'll find most batteries are here on the drop-down list. Some of the batteries which are not on our global compatibility list, they may be on our secondary compatibility list. For those, we might select GoodWe factory defaults for communication. And next, we go into advanced settings. Sorry, one thing I forgot to mention, which you'll see at the top of the page. So once you select any of the settings, it will ask you for a password. And that password hasn't changed since 2010. So it's GoodWe 2010. So sometimes it will be a capital G, sometimes a lowercase g. But you can always use a capital G and it should always work. So in here we can go and enable our export power limitation. So when we enable this feature, then we can select here. So if we're not allowed to export at all, we'll set 0 watts here, and then we'll set and it will be enabled, and 0 export will be on. If we're in a country where we're allowed to export a certain amount, so if we have a 6 kilowatt inverter, but the utility says I'm only allowed to export 3 kilowatts, then you can select 3 kilowatts there, and then the inverter will limit it up to a maximum of 3 kilowatts of export. And we have shadow scan. The shadow scan is used for heavily shaded installations. So if during the peak of the day you have quite a lot of shading, then you can use shadow scan. But if it's just in the early morning and late afternoon, it's not good to shadow scan. Connect your backup supply. So in most cases, when you have multiple power sources to the device, the backup supply will automatically be activated. Next, we have the grid changeover speed or detection. So it's always recommended for full detection of equipment down the line, as well as seamless changeover to have full wave detection. With full wave detection, you'll have your 10 milliseconds changeover. You can select half wave or wave right through. That will delay the changeover on the backup. That's used for areas where we might have momentary voltage spikes slightly above the grid recommended or slightly below the grid recommended voltage. Give the inverter a bit more time before it disconnects from the grid. Only if we have very volatile grids that jump up and down, we can adjust that. But if we want the inverter to disconnect to protect equipment, we can leave it on full wave detection. So then we have the advanced settings. In the advanced settings, we've got a few more things. You'll see like the power factor, clear overload history, things like that. So power factor, typically we do not touch, especially in domestic applications. When we have commercial applications, we can adjust the power factor if need be. Sometimes when the power factor on a commercial site is bad, we can adjust this to improve the site's power factor. And that can also reduce their bill, because when you have a lot of reactive power, an inverter producing at a nice 1 positive power factor, that can actually make the site's power factor worse. So with this, it's a bit more fine tuning. You have to assess what is the site's power factor with a meter, and then adjust the power factor up and down until you improve the site's power factor. The majority of installers do not touch this, but on bigger commercial sites, it's always good to check the power factor of the site, because a perfect 1 power factor on the output of a device can negatively impact the power factor of a site. Next, we have clear overload history. So if we do overload and trip the device off, essentially it has an overload timer. So that timer is maybe 5 seconds, and should it trip a second time, it will then be 10 seconds, then 20 seconds, then 40 seconds. So the timer doubles each time. If a customer is regularly overloading the device, the time can get quite long. But with the ESG2, typically you won't see a lot of overloads that could shut the inverter down, because we can overload so high for quite a long time. It's only when we only have batteries available that it might trip off. The next, we have custom safety parameters. So if you do select a country safety parameter, but you have special requirements, you are welcome to also adjust this. So if you have a country that has very specific requirements for the inverter connection, you can come and adjust these values individually. Next is a communication address. The communication address is only really used when we are paralleling or connecting to EMS devices or third-party devices. Then we can change the communication address for the RS485 bus. Next, we have arc detection. As I mentioned, that optional extra that you can order. So if we are seeing arc detection faults and we've not ordered it with the device, we can go in here and just make sure that the function has been disabled, or sometimes it might be enabled by default. Lastly, we have some other features like the remote shutdown or dread connection for Australia. Yeah, we can disable that. We also have a PE to neutral relay. So depending on country codes you select, this will be enabled automatically. 50 Hz default will not be able to work with the pen relay. That's your earth to neutral relay. And then lastly, we have the dynamo, but I've got another screen for that. So let's first go down to battery. So we've got our battery selection. So in here, you'll see it opens a new screen. So in here, we've got a few functions that we can do. So immediately charge the battery. So if you are on site and your batteries are very flat and you're expecting a power outage or anything like that, you can use this function to immediately start to charge the battery from the utility. Same if you're doing a new installation and maybe it's going to stand for a while, just charge the batteries up to their full before you shut the system off. Here you also see there's charge voltage, charge current, and discharge current. These values, the charge voltage, the charge current, discharge current, are all dynamic values from the battery BMS. And when we select our battery type, it will select some default values. But these values that are displayed here are all dynamic values from the battery BMS. Then we have SOC protection. This should always be on. This ensures that the batteries do not overcharge and that the inverter listens to the battery when it stops charging or discharging. Here we've got two settings: on-grid depth of discharge and off-grid or backup depth of discharge. So these discharges aren't linked. So if you want to use some of your batteries for self-consumption and save the rest for backup, you set here the amount of battery you want to use during an outage. So if you only wanted to use 10%, then you could set here and set 10%. And you press set, that means we'll use 10% of the battery, which means the battery will remain at 90% state of charge. And yeah, for the off-grid, typically we leave this at the default value for off-grid scenarios. So this battery can go to 95%, that's on here. So we'll use 95% of the battery when the grid fails. As I mentioned, that immediate charge battery settings, you can set the cutoff. So if we only want to charge a battery to 50%, we can also set the amount of power to charge the battery. So if you want to slowly charge or charge very fast, you can select the percentage of the charge rate, so the maximum rate based on the BMS, and then at what SOC we should stop charging. So this will charge the battery. Once it hits the cutoff SOC, this will go off again. Then looking at dynamo control or generator, we'll probably change it sometime to generator. But yeah, we can control that generator relay that I mentioned earlier, as well as the power. One thing that's important to keep in mind, is that the smart meter must be off when the grid is off. Even when you're running a generator, the smart meter needs to be off, because it's one of the flags for the inverter to tell that the grid is off. So if the inverter has a voltage on the grid input and the smart meter is off, it will then presume that a generator is running. It's very important to keep that in mind. Here you can select the rated power of your generator that's connected to the device. If the generator is slightly smaller than the inverter, which is not recommended, you can set that there. So if you only want to use the generator, make sure your loads are off and you're going to manually start to just charge the batteries. That's fine. Yeah, you can select the generator's rated power, which means the inverter will only consume that maximum power. You can also switch it from auto or manual, so manually turn it on or automatically turn it on. So when it's on manual, you can put the switch to say switch generator on. You can also select the maximum amount of time you want your generator to run. If you only want to run it for a certain amount of hours, the upper voltage of the generator, lower voltage of the generator, the frequencies we can adjust here. The delay before charging, so the delay before the inverter connects to the generator. So you might want your generator to auto start. You want it to warm up a bit first before we put the load on and start using the generator. So yeah, you can select maybe 60 seconds or more, and then it will wait a bit longer once the generator is started before it connects to the generator. And next we can do the charging switch. So to charge the batteries from the utility, from the generator, you can select the maximum charge power and the turn on and turn off SOC. So the turn on SOC, which will mean if you're running in an off-grid scenario, once your batteries reach that percentage, it will automatically close the relay, which will then start the generator. The generator will start up, it will have the delay here, will then connect to the inverter. The inverter will start to charge the batteries. And then once the batteries reach 90% or 100% or 95%, switch off. So it will switch the generator off and then continue to work. It's very important, that we make sure if we're connecting a generator, that the generator is large enough to cover the loads, especially the non-essential loads, if the generator will be connecting to non-essential loads as well. And then that there is sufficient left over for charging, that we do not overload your generator. Okay, next we have the firmware update with Bluetooth. So from the SolarGo app, if you connect to the inverter with Bluetooth, as I showed in the beginning, sorry, these are slightly older screenshots from the app. So once you're in Bluetooth, you'll get a notification that will say there is a firmware update for the device, or you can go to the settings page where you'll find firmware update. There you'll go in and it will show you what is your current firmware and what version is available for updating. You'll select upgrade, it will give you a reminder, and you'll see the upgrading and the upgrading bar will run. Once it reaches 100%, it will give you a notice and say, please note that the device is restarting, and you'll be redirected to the home page. So once this is 100%, you'll probably have to wait another 5 or 10 minutes for the inverter to do its reboot. Never restart the inverter, never switch the inverter off when doing a firmware update. Always leave it until it is finished. The only thing you can do to check it is try and connect to it via the app again. If you can connect to the inverter via the app and you are getting data from the inverter and you can verify the firmware version, then you know it's complete. Never think like, maybe it's taking too long, I need to restart it. Never do that, because if it's busy writing the firmware to the flash and you restart it, you can cause the inverter to not have any firmware on it. It's very important to make sure we have a stable power connection and we do not switch it off during this process. So then we'll go over to paralleling. So if we are paralleling the ES inverter, we'll make sure to complete everything else that we've already gone through on each inverter individually. So we make sure to commission them, make sure to do all the settings on them. Each inverter will have the same settings on. And then we will go into paralleling. Now that everything's commissioned, everything is set correctly, our battery's connected, our grid's connected, all of that, we make sure to have the backup loads off. In this scenario, it's always good to make sure your battery cables are the same length and your backup output cables are the same length. It's a default rule of thumb for any parallel system, not just the GoodWe parallel system, but to make sure you have equal potential between the outputs to have a perfectly balanced system. You'll see the EasyLink. The EasyLink installs to the master inverter. The communication between the inverters. So the EasyLink is the only optional accessory you can purchase. So with the EasyLink, you'll get 2 cables to connect to have 3 inverters connected. Then you connect your inverters via RS485 to one another. You'll see the smart meter is connected just to here. So there's 2 scenarios. This one is separate battery banks for all our inverters. The alternative scenario is having the bus bar with a large battery bank connected to all of our inverters. So for that, you'll see it will be run through here, connected to the master inverter, the battery communication. There is also then configuration we do on the EasyLink, which you do not have that for us today. The configuration on the EasyLink, we can just select in the scenario that it is a parallel battery bank. And then you'll see the smart meter here on the master inverter. Once they're all connected, switched on, we've confirmed on the EasyLink the number of inverters. You can see all the inverters connected to the EasyLink. Once they're all happy, all the LEDs on all our inverters should be happy. And then we can switch on the loads to backup. So this is just a look at the EasyLink. It's the only optional accessory that you will need for paralleling the ES generation 2 device. So please keep in mind, you do need this parallel. The EasyLink also has built-in Bluetooth. The EasyLink has LAN as well as Wi-Fi. And in the parallel system, we do not have any Wi-Fi modules connected to any of our inverters. We only have the EasyLink connected to the master inverter. All the communication will be handled for the entire plant via the EasyLink. The next is the SEMS portal. We might be. I don't know how we're doing for time there, Lindy. I'll try and run through this a bit quicker. On the SEMS portal, we can get a lot of information, accumulate the data in the individual plant, the last reported PV power, our battery percentage, nice system graph with the load, power, export power, limit meter. On three-phase devices, if you want to see a nice graph with individual load, individual phase loads, individual meter readings, you can also click on this button here, and it will take you to a nice full screen page to have an individual look at the graph of the three-phase inverters. System overview here is what you've configured. Your weather forecast is based on the location pin you set on your plant. So when you select the location pin, it will give you the approximate weather data from the closest town center. Always select your closest town center on that pin for the weather forecast. Next, you've got your linked devices. We also have the flow diagram. If we have multiple inverters here, we'll have dots here. Up to a maximum of 4 inverters, we'll have dots. And if we have more inverters than that on a plant, so on a commercial plant with on-grid inverters, then they will come into a list and we'll have a list of devices. Here under device information, we've got a lot of information, the serial numbers, the check codes, we've got our temperatures, the wattages, the voltages, all of that information, your DC currents and voltages, your battery current, voltages and currents, the status of the battery, any warnings from the battery, dynamic values from the battery BMS over here as well. And then we have device firmware. Next, we have the curve. The curve here, if you want to see individual graphs, breakdown graphs of anything. So yeah, you'll see here's the detailed graphs. You can come in here. First, we'll have power, which will be the same graph as above, but the individual inverter graph. Here you can go and view your voltages, your currents, all of this information in a nice diagram format. Then the SEMS app, adding a new plant. So the easiest way to create a plant is the SEMS mobile app. So you simply create the plant, input the owner's information, plant information, all of that here. With the install account, as soon as you put an owner's email address in here, so the end user, if you put his email address in there, it will automatically create him a SEMS portal account. When you do that and you submit it, you'll see there it will give you a notice saying a new email has been registered, and it will give you the default password. So the default password might not always be GoodWe 2018, but when you register it, it will tell you what the password is for that account. You can provide it to the end user to log in to view his system. Then once you've created it, it will ask you, do you want to plant successfully created? Do you want to add a device, you can say immediately add or not now, and then click the blue add later as well, or you can just say immediately add. You can scan the QR code on the inverter or manually input the information. The QR code is there for your convenience so that you can just scan it and populate that instead of typing out and check. Then the plant will be added, everything will be created, and we can see the plant on the portal. So should we have connected the Wi-Fi up to the customer's network, we've created our plant on SEMS portal. Now we can't see it online. We can check to see what is going on. So the inverters have LEDs. The new modules also have LEDs to show us the connection status. So if we cannot find the Wi-Fi access point, or we can see it, but we cannot connect to the solar Wi-Fi, or we connect to solar Wi-Fi, but we can't go to the address. So if we want to go to the widget, so some of our devices, we can do the Wi-Fi configuration from the SolarGo app or from the SEMS portal app. But if that fails, we can also always connect to the direct address, which is 10.10.100.253. Go into the module itself with the default password admin. Username and password is admin. So this is also applicable. So if the customer's changed networks or he has a new router or anything like this, then we need to reset the Wi-Fi module. So we can press and hold the reset button. It will be in different places on different devices. And all the new Wi-Fi modules has it on the Wi-Fi module directly. You can press and hold that for 5 to 10 seconds. And that will fully reset it and clear the previous Wi-Fi settings. Next, we can check to see that the device is visible from the app configuration or from the web interface configuration. I prefer the web interface because we have a nice numerical view of the signal strength. Always important to make sure this is above 40% signal strength. Even sometimes 40% if there's a lot of interference between the inverter and the Wi-Fi, can cause it to drop off regularly. And lastly, there's a few other scenarios that we can look at the LEDs flashing. But typically, we'll have a two flash or full flash. Some of our new devices might have different indications for the LEDs. So please just keep that in mind. The two flashes means it's not connected to router. So we might have typed in the password incorrectly or something else may be wrong. And next is full flashes. Full flashes means it's connected to the customer's network, but it's unable to speak to the SEMS portal. So when we're getting full flashes, normally it's not a connection problem. The inverter is connected successfully to the customer's network, but there is a communication issue between the inverter and the SEMS portal. So we always need to make sure that there is no firewall blocking the communication. Very often home routers, so if you have a plant that maybe works for 2 weeks or 3 weeks or 1 month, and then all of a sudden it stops working and goes to full flashes. You reboot the inverter, it works again for that 3 or 4 weeks, and then goes back to full flashes. That's an indication that a firewall is blocking the communication. Home routers, all our firewalls, they're all terrible. And that's why it takes 3 weeks to a month for them to block the inverter. But a lot of our devices have new firmware on that should circumvent that. So for the home routers, it will automatically reboot the Wi-Fi, get a new IP address, and be no longer blocked by that home router. But on commercial sites where they have good firewalls, we'll immediately block it. And then we have to speak to their IT company to resolve this. We can also just verify that there are no unsupported characters or blank spaces in the password or the username for the Wi-Fi. So there's a list of supported characters. So any other characters will not be supported in the special character range. And blank spaces like my space home will also cause this to happen. So then with the three-phase devices, so after installation, sometimes we can have the devices stuck in a fault mode. But because we didn't do the installation of the three-phase inverter, I thought it's very important to cover this. So the most common reason for that inverter not to connect to the grid and remain in a fault mode will be phase order fault. So the inverter always checks the phase rotation. So it always has to have a right-hand phase rotation. So very often we can swap two of the live 2 and 3 on the AC terminals, and then switch it on the grid back onto the inverter. If the error is cleared, then we know, wonderful, we've solved the issue. We can continue. But it's very important when we do this, if we swap the lives on the inverter, we're using zero export, we're using unbalanced output function, means we need to swap it by the smart meter as well. So unless we've swapped the phases by the utility coming in, then we just swapped it by the inverter breaker or under the inverter, we need to go and swap it by the smart meter as well and move the CTs around to the correct phases. So that's very important. So if the meter is not installed correctly, we will see a lot of strange data. The constant export at night, our batteries are remaining full and not discharging to loads, and the load doesn't make any sense. If we do have any installation issues with the meter, then this might be the cause. It's very important to verify on SIMS portal after your installation. I know we do have the meter test. You can run the meter test. It does work in certain scenarios, but sometimes the meter test is unable to accurately judge CT direction or the CT placement. So we always verify this on SIMS portal. I say on the three-phase, you click that plus icon I showed you earlier, you'll get a nice graph where you can go and view and see what phases, if the phases are correct or not. We should always see consumption at night when there's no battery discharge. Here's a nice example of a customer who had a phase rotation error. They rectifies the phase rotation error. We then left the site, zero exports enabled. It shouldn't be exporting to the grid. The customer then phoned and complained and said the inverter is exporting. Zero exports enabled. Why is it doing this? So the first thing I did, I used the curve on SIMS portal to find the meter phase that was showing me the export we are seeing. Then I went to IAC, the IAC. So IAC is the AC output, the grid output of the inverter. I can see it on phase 2. The meter's on phase 2. On phase 2 on the inverter, we have no power really coming out then. But on phase 3 of the inverter, we see all the power which matches the export power on the graph. So clearly the customer swapped phase 2 and 3 on the inverter, but they did not swap phase 2 and 3 on the smart meter. So with the unbalanced output, as we know, it was reading load on phase 3, but it's outputting it on phase 2. So very important if we fix the phase rotation to fix it on the smart meter. Let's look at the after-sale service. So if you've done all that troubleshooting and fault finding and installation and you still have some issues, then obviously you'll want to connect to our after-sales service. The after-sales service offered by our GoodWe EMEA, GoodWe Europe, Africa. We have local technical support in countries. So in Kenya, we have local technical team members. South Africa, we've got a local service center. So in the EMEA region, we have 10 local hotlines for our technical support. We still need to set up a hotline for Kenya as well. cover over 11 languages. We have 8 warranty stock locations. So for Africa, currently, we only have warranty stock in South Africa, on-site technical support in certain cases, and repair services in certain countries. Here's an overview of the services we have per country. As you'll see, for Africa currently, we have a bit of a limited ones. In South Africa, we have on-site technical support, we've got local warranty stock, and we will have repair services in South Africa soon as well. We have competent local technicians. We do remote troubleshooting and commissioning support. They are supported by level 2 engineers within the EU time zone, such as myself. We have flexible resources with service partners to adapt to our growth. We do quality control by unified ticketing system, closed system across the MEA, and we are KPI driven and always strive to solve issues as quickly as possible. How to contact our support. So for most of Africa, we will use the South African call center for support. Please do not call the other centers because they will generally refer it back to South Africa, because majority of our other centers do not have access to the African server inverters. So how does GoodWe's after sales service work? So we have an after sales inquiry by a customer, so either via our hotline, via our technical support online, or the online ticketing system. We then go through troubleshooting. We provide the troubleshooting steps, what problems could be. We assess the data of the device online connected to the SAMS portal and offer that support back to a customer. Should that not be sufficient, we can then do a product replacement. So in South Africa, we can ship a direct placement to the customer where they can then replace it. In other countries, we would normally, where we do not have local stock, you would then approach your distributor and request a replacement from your distributor. So once a device is then replaced and the faulty device is returned to your distributor or to us, then we will inspect the devices to make sure they were defective, and then confirm the warranty. And that is all for our presentation. We do have quite a bit of time still, so if there's any questions, Q&As, anything like that, please do let me know, and I'll try and answer.
Maybe on my end, it's just to thank you for attending our first Africa Pro Sales training. This is more of residential. We will have a follow-up later in a few weeks on the commercial and industrial solutions. Thank you so much.